Hello all. Welcome to this next video where we discuss the software design of our DPR project. So in the previous video, we have completed the bitstream generation. So we have created the bit streams and converted them into these .bin files which we did. So I copied all these bin files in this folder. These are the files that will go to our SD card, which will be used for the partial reconfiguration, right? So let's see. Now, we will be using PCAP interface to transfer our bit streams from the SD card to our FPGA fabric. So the PCAP is a part of device configuration, DVC, the PS, right? So the device configuration DVC, it contains a PCAP interface as well as other interfaces. So to know more about this PCAP interface, we can go to this technical reference manual and see this PCAP database data path configurations. Now, this is the flow that we'll be using. So basically, PCAP has like it's an interface. It has its own DMA, which is used to transfer the bit streams from either from the on-chip memory or from the external DRAM to the PL fabric. So the flow that we are going to use is that we will be having our bit streams in the form of .bin files in the SD card. Then the PS will be used to read the SD card and transfer those bin files bit streams to our DDR memory. Then PCAP interface will read our bit stream from the DDR and reconfigure the PL module. This will be done for full reconfiguration as well as for the partial reconfiguration cases, right? So let's move on to our PL flow or PS flow. So first we will just export the hardware. I've already done it, so I won't do it again. We will export the hardware, uncheck the include bitstream. We will include the bitstream later. Okay, and click on OK. I'm clicking on cancel because I have already verified it and tested it. All right, and then go to launch SDK. All right, so the SDK is open, and as I said that I already tested this project, so I have all the information, all the projects, I have already all the files I have in this one. Basically, you just go to your normal flow, new application project, and then do your normal programming. I will only explain the part that we will require for the partial bitstream configuration. The first thing we need to realize is that because we are reading our data from the SD card, so we need to modify this BSP settings to include this ZIL-FFS library, okay, generic file system library. By default, it's not ticked, so you just click on it and click on OK. So it will include this now ZIL-FFS library in our host files. All right. So let's look at this code. No, this is the code which uses which sends the data to our STATRFID and gets the back for the channel estimation. I will not be explaining the code regarding the channel estimation, but however, I will only discuss the main parts which are used for the full bitstream configuration as well as the partial bitstream configuration. Right. So we will start with the this the platform start. That's okay. Then this is used to basically initialize our SD card. Okay, so I have all the files in the SD card.c and SD card. So we will first initialize our SD card. Okay, SD card in it, it will mount our SD card in the path O. Okay, and then once initializing, then we can read and write from the SD card. So there are other functions also in this SD card.c. So first is the initialization, where we mount our SD card. If there is some error, it will return the error, or it will return this it has mounted success. The other function that we'll be using is the eject. Once this we have read or written anything to the SD card, we need to eject it. So this is what we are going to use for SD card. You can use these files, these functions as it is, as given, and we have to make sure that the path has to be same. So this is O and the same path. So this will be used for ejecting. This is the function which will be used to read any file from the SD card. Okay, so we will have to pass on the file name and the destination address. So as I said, we will be reading the file from the SD card and storing it in our DDR memory. So that's what we need. We need the file path of the SD card, and then we need the destination address, right? And within this read file, so it will first open the file, okay, in the read mode, file name. Then we will be like getting the file info, which will give us the file size. Okay, and basically these in here we are using these functions to basically read our files. Okay, so this is what's going to read the contents of a file, and then once read, the file will be closed. The flushing of the cache, and we will return the file size. All right. So basically, it reads the file and returns our size. And then the write file, if we need to write anything on the SD card, we have to do the same thing, give the file name where we want to store, size, and the source address, the address of the file which we, source address of the data. We won't be using write file in this project. However, the read file will need to read it, use to read the data, the bit stream from the SD card. Right. All right. So the first thing that we'll use is this. We will initialize the SD card. We will also need to initialize the PCAP interface. So this is the init PCAP. If we look at it, it will be in our pcap.c, which is also given here. So pcap.c, pcap.h, sdcard.c, and sdcard.h. These are the four files that we will require. So we have also already defined this init pcap, where we are going to send the device ID and this device configuration. Now it's going to initialize it. We won't go into the details of it, but however, we first need to initialize our. So that's it. So we have initialized the SD card as well as we have initialized the PCAP. The next thing would be to reconfigure. As we see that we have not like programmed our FPGA model. As I said that we will program for both full as well as partial reconfiguration our FPGA using the this software flow, right? So right now we are everything there, the FPGA does not have any bit stream loaded. So what we are going to do is that we will first use this full reconfigure function to use this full dot bin, okay, to read the full dot bin. It's the name of this one, and we will full reconfigure our FPGA. So if we see, the inputs to the full reconfiguration function will be file name, this device instance, okay, device configuration instance, and the bitstream buffer. Now, the file name will be the file name on the SD card. So we will see on the SD card, we will have this, we will have a folder by the name DNN, and within this, we will have a full dot bin, okay, which will contain our full bitstream. So file name, and then we will pass on this device configuration. Okay, device configuration instance, we have already defined it here, right? So during the init pcap one, we pass on the device ID and this device instance device configuration. So all the information regarding the pcap is in this way, structure. So we have it here, we pass it, and then the bitstream buffer. Now Bitstream buffer is basically a buffer which will store our which will store our bit stream in the DDR memory. Okay, so if we look at this one bitstream buffer, its size has to be equal to the full bitstream size because it has to contain the full bitstream, so its size has to be same. Now, how to find this size is that if we look at our this one, so this is a full STA which we will rename as full. So if we look at the properties of it, this this one 1332140 bytes. Right? This is what this size is 1332140. So we will go here, see the size, right, and copy it here. It has to be of the same size or greater because this buffer has to accommodate the entire bit stream. Okay. File name, device instance pointer, as well as the full bit stream buffer. We will send into the full development. Then first, as I said, it will read the file. So read file will read the file from SD card to our bitstream buffer, which is in the DDR memory. Okay. Then it will return our size. It will return the size of the return the number of bits that it has read, number of bytes. Sorry. Now we must remember that when we transfer the data, okay, it will be U32. It will be 32 bits, and the read file will give us the number of bytes. So how many transfers do we need? It will be status divided by 4 because for each transfer we will be transferring 4 bytes, right? So that's the bit stream size. So and then now these are the these are the configurations that we need. Clear pcap status. These are defined in this pcap.c file. So we won't go into these, but these are the configurations that we require for this full bit stream. No, we have to do this clear pcap status, fabric initialize. We can use them as it is. Now, this is something that I can talk about. It is the X device configuration transfer. As I said, that pcap uses the DMA to transfer the bit stream. So this is a sort of a DMA transfer function. If we open this declaration, we can see that this function starts the DMA transfer. So what it does is that it starts the DMA transfer, which basically reads the data from your buffer, where we buffer from the DDR memory, where we have stored the bit stream, and transfers it to the PCAP interface. So first we will send in this device configuration instance pointer. So this is the PCAP point instance pointer that we have used. And then bitstream buffer. So this is the data location where this is the address of a data where our bitstream is located in the DDR memory. Bitstream size, how much is the size of 32 bit in the form of 32 bits, how much data we have to send. And then now this basically should have been the destination address, but because we are using this PCAP DMA, we don't need to write any. So this can be anything, and here we have written this DMA invalid address, but it doesn't matter. We are not doing anything. So this should have been the size, but again, as I said, because we are using this for the PCAP DMA one, it doesn't matter. So it's 0 in here. Now, this is one more thing which has to be seen. So we can see that it's the non-secure. As I said that we are not using the secure transmission, so it's not encrypted. So we have to pass in this value, okay, XGFG non-secure. So what this line does, what this function does is that it transfers our bit stream from the bit stream buffer to our fabric, to the FPGA fabric. All right. And because this is a DMA transfer, we either have to use the interrupt or the polling method to know when the DMA transfer is complete. So in this case, we will be using the polling method. So this is it. XSG poll done. So it's already in this pcap.c. So what it does is that it gets the status, and while its mask value is Like while it's polling it, if it's not completed, it will be in this while loop. Once complete, that means this polling is done, the transfer has completed. So that's it. So that's what we are doing. First, we need to read the file from the SD card to our DDR memory, then see the size of it, some initializations, okay, transfer from DDR to the FPGA fabric using this DCFG transfer, where we pass in this instance pointer which tells it to use the DMA associated with the PCAP interface, and then we are porting it. So that's it, right? So this thing is nothing, it just gets the interrupt status, we can skip it, it's not needed. All right, so this is the process of the full reconfiguration using the SDK. Now, once the full configuration is done, uh, we can run our software program, software implementation, right? The hardware implementation which is required. So you can run your program as you want. Now we will focus on this DPR one. Well, now we have now we when we want to do the DPR, we have to do this partial configuration. Okay, and for the partial configuration one, it's the same, almost the same. So we have this partial reconfiguration where we pass on the file name. Again, this is the file name for the partial bit stream that we have, right? And then device configuration, which will again be the same, the PCAP interface instance, and the bit stream buffer, again the same bit stream. All right. So what happens in the partial reconfiguration? It is basically the same, almost the same thing as a full reconfiguration. First, we will read the file, bitstream file. Okay. Then some like interrupt clear, we will clear the interrupts, and then again the same X DCFG transfer. Now it's the same thing that we have done using this instance with file instance of the PCAP, bitstream buffer, bitstream size. Now here, because we are reading the bitstream for only the partial bitstream one, so its size will be different. It will be smaller. If we look at the size, so for the partial one, it's this 575. So it's basically 5.48 MB. The full bitstream was like 13 MB. Okay, so that's it. And then the same invalid address and non-square. And then we will go with the polling. So here we are just writing it as it is. The XCFG get this one. So if we will get the status, all right, of it. If it's done, if it's not equal to this, then continue with in this while loop. Once it's completed, we can move out of it. All right. So that's it. So we are using this method, and once it's completed, okay, once the transfer is completed, oh, that's it. That's the partial reconfiguration. Okay, so yeah, so that's basically the software flow for the partial reconfiguration. If we have to summarize it, you can say that first we read the data from the SD card to our DDR memory. For that, we need the functions from the read file function from the SD card.c. Right, this will be in this the code base that we will share. Okay, and then we will need to transfer the bit stream from the DDR memory to the FPGA fabric, which will be done using the PCAP interface. All right, so that's it. Thank you. Now we will have a demonstration of this DPR program that we just did. So let's run it with our normal usual configurations. Run configuration. Uh, program FPGA is unticked because we have not imported bitstream. We will do this program FPGA using our PS program, right? So application it's so run and session, yeah, okay. And you can see we have this warning sort of that done pin is not high on target FPGA. This is because we have not yet programmed our FPGA. So that will be done using the PS, using the full reconfiguration. So for now, let's click on yes. And first it will reconfigure our FPGA with the full configuration bit stream that we have provided. So we can see that it's done, the full reconfiguration has completed, and we can see the output of the result. All right, and now it's for the partial reconfiguration. So let's first use the option one, and we can see this partial reconfiguration has started, and we can see this the result has changed. So uh, it has been reconfigured. So we can also do two TRFI, and we can see that our result has changed again. So by this we can see that we are able to partially reconfigure using our PS program, and we were able to fully reconfigure as well as the partial reconfiguration using the PS. So this completes this tutorial where we showed the partial reconfiguration flow using the HLS generated hardware IPs. So thank you all. If you guys have any comments or any questions, please feel free to mention in the comments.